In this lecture, we're going to see how references can be really useful if we are trying to modify data in a range-based for loop. Here we have a simple array called scores. It is initialized with data from 1 all the way to 10, and it is an array of integers. Down here we have a simple range-based for loop that is going to loop through and print each element in the array, and this is going to work fine. This is going to be until we want to modify the data through our range-based for loop. So if we set up something like this, for example, for auto score in scores, and inside the curly braces we try to assign a new value to score, this is not going to modify the original data. This is going to be modifying a copy of the current iteration in the array that we have in this loop here. And if we try to print out, we're not going to see our changes reflected in the original array. And this is frustrating because we really want to change the data that we have in our array. References are going to be on the rescue here. We can modify our for loop a little bit and say for auto reference score, and the score variable we're going to be having in our loop is going to be a reference to the original element in the array at this current iteration here in the loop. And if we modify data like this, we're going to see our changes reflected in the original array. Okay, this is really all we are up against in this lecture, showing you that you can use references to modify the original data in your range-based for loops. We are going to head over to Visual Studio Code and see this in action. Okay, here we are in our working directory. The current project is references with range-based for loops. We're going to grab our template project and we are going to put in the files here. And we are going to open this in Visual Studio Code like we always do. The first thing we want to do is to set up our array and try to print data from it. So let's do that. Let's put some line here so that we have some breathing room. And this is code you've seen 1,000 times by now, so we don't need to explain it. It is basically an array of ints, and we are looping through, printing each element through a range-based for loop. So we're going to bring up a terminal and see this run through the compiler. So let's do this with GCC. The build is going to be good. And if we clear and run Rooster, we're going to see our values printed out on the console. This is nothing new. But now we want to go through a range-based for loop and modify each element in this array. And the way we can do that is try to use a for loop like this. And inside, we're going to assign to the score variable and do something like, and assign it a value really. Let's grab whatever element was in score and let's multiply it with a value like 10. This is going to be easy to follow. If we do this, we would expect the original array to change from 10 to 100 because we just multiplied each element with a 10. But if we do this, we won't be modifying the original array. The way C++ works, if you use a for loop like this score variable you have at each iteration in the loop is a copy of the current element you have at the current iteration. So if we are looping for the first time here, it's going to be a copy of this one. It's not going to be a pointer or a reference to this one. It's going to be a copy. So what you're doing here is basically going to be affecting the copy, and that copy is going to be lost the moment we go to the next iteration. So if we print again, we expect to see the same data. So let's do that. We're going to print again. We're going to grab the code to print here. Let's also grab the new line character here so that it is easier, and say that we are printing after change here. This is going to be enough. Now if we try to build, we would expect to get the array here changed to 10 through 100, but that's not what we're going to see. Let's prove this through the compiler. The build is going to be good, so let's clear and run Rooster, and you're going to see that we still have the same thing. This is not what we want. If we want to affect the original data, we would have to go through something like a pointer or a reference. But in C++, the syntax that is supported is that of using references, and that's what we're going to do. And the way you do that, you say for auto and you say reference like this, And the moment you do this, this score variable is now a reference to the current element in the iteration. So as we go through, it's going to be a reference to the 1, a reference to the 2, a reference to the 3, and we're going to be changing these elements here. And notice we don't want to use the reference here because we are just printing elements. But for this loop here, where we want to change the elements, we're going to have to use a reference for our changes here to stick through the original array, if I can say it like that. And you're going to see that if we try to run now, we are going to see that the changes now have reflected in the original array. You see that now we have from 10 all the way to 100. And this is one area where references shine in C++. They are going to help you have your changes be reflected in the original data. And this is just a tip of the iceberg in how useful references can be. We're going to see many more uses as we progress in the course. For now, we are going to stop here and head in the next lecture where we are going to recap what we saw in this chapter. Go ahead and finish up here and meet me there.